Practice 2, question 7. Another long one. In a lab investigation, one group of students, Group A, measures the speed of a 0.1 kilogram toy car to be 2.5 meters per second at the bottom of the ramp. Another group of students, Group B, measures the speed of the car to be 3 meters per second at the bottom of the ramp. The car's starting position at the top of the ramp is 1 meter high. What is the potential energy of the car at the beginning of the experiment before its speed is measured? So I am looking for the GPE. That's going to be my question mark. And then my given is I know the height is 1 meter. The acceleration due to gravity is 9.8 meters per second squared. And I know that the mass of the car is 0.1 kilogram. My equation for GPE is H times A times M. So GPE equals 1 meter times 9.8 meters per second squared times 0.1 kilograms. Take my handy calculator. 1 times 9.8 times 0.1 is 0.98 joules of potential energy. That's just the first part. Now that we know that, let's compare its kinetic energy. So part B, calculate the kinetic energy for the car for Group A. So its mass is 0.1 kilograms. Its velocity for Group A was 2.5 meters per second. I'm looking for KE. KE is equal to 1/2 mv squared. So 1/2 times 0.1 times 2.5 squared. 2.5 times 2.5 gives me 6.25. So I have 0.5 times 0.1 times 6.25. I end up with a kinetic energy of 0.3125 joules. Now for the same car, but for Group B, I'm looking for kinetic energy. My mass is still 0.1. My velocity this time is 3 meters per second. So I'm going to plug in my equation, 1/2 mv squared. 1/2 times 0.01 times 3 squared. 3 squared is 9 times 1/2 times 0.01, or 0.1. So 0.5 times 0.1 times 9 gives me 0.45 joules.